In this video, class 8, we are going to look at pressure. Okay, so let us first start with its definition. Pressure is defined as the thrust per unit area. I believe all of you have checked the previous video on force and thrust. Okay, thrust is basically a force which acts normal or perpendicular to a surface is what is called thrust, don't forget. So pressure is defined as thrust per unit area. This is how you write mathematically this statement. This is how this statement is written mathematically. Pressure is thrust upon area. So it can also be written as P is F upon A. Since thrust is basically force, so therefore we are denoting thrust by a capital F and area by A. So force, thrust upon area is what is called pressure. Now let us look at its unit. Since pressure is a physical quantity, it should have a unit. The unit of force is Newton, SI unit. The SI unit of area is meter squared. So it is Newton upon meter squared or Newton per meter squared, also written this way. Capital N upon meter squared. Now this Newton per meter squared is what is called a Pascal, denoted by a capital P and a small a, Pa. So this Pa is what is the SI unit of pressure, remember. The other units, kilopascal, denoted by small k, capital P, small a. So kilopascal, 1 kilopascal of course is 1000 pascals. The other unit is denoted by ATM. Okay, this means atmosphere, and it of course is the pressure exerted by the atmosphere. We have atmosphere surrounding the earth. All right, so therefore the pressure exerted by the atmosphere is what is called 1 atmosphere. Okay, 1 atmosphere. And we see that 1 atmosphere is equal to 1.013 into 10 to the power 5 pascals. So this many pascals, 1.013 into 10 to the power 5 pascals is what is called 1 atmosphere. This is quite a huge amount of value, remember. Now this 1 atmospheric pressure is also equal to the pressure exerted by 76 centimeter of Hg, that is mercury. If we have 76 centimeter column of mercury, then the pressure exerted by that liquid mercury is what is equal to 1 atmosphere. Let us now look at the factors affecting pressure. As you can see from the equation for pressure itself, pressure depends on two factors. One is the force or the thrust acting and the area on which the thrust is acting. So let us look at factor number 1. Factor number 1 is the area of the surface on which the thrust is acting. So mathematically we write pressure is proportional to 1 upon A, or we read this as pressure is inversely proportional to area. Now what does it mean? It means that whenever area decreases, the pressure increases, and whenever area increases, the pressure decreases, remember. Okay, so this is what is called inversely proportional. You just understand inversely proportional this way for now. Whenever area decreases, pressure increases. Whenever area increases, pressure decreases. Okay, so this is how pressure is dependent on area. To give you an example, we have the same boy wearing different colored clothes, of course. Okay, one case number 1, he's standing, and the other cases is lying down. So the weight of the boy in both the cases is the same. Weight is a force, don't forget. So the weight of the boy in both the scenario, it's not changing. All right, but in this case, in case number 1, the pressure exerted by the boy on the floor is more. Why? Because his weight, that is the thrust, okay, which acts normally on the surface. So the thrust or the weight of the boy on the surface is acting on a small area right now. So since the area is small, the pressure exerted by the boy in this case is more. Whereas the same thrust is acting in this case, but the thrust or the same weight of the boy is acting in this case. Okay, but the weight of the boy or the thrust is acting on a bigger area now. Since the boy is lying down, the weight or the thrust is acting on a bigger area. So since the weight or thrust is acting on a bigger area, so therefore the pressure decreases. Pressure is lesser in this case. To give you another example, that of a nail. This is the blunt end of the nail. This is the pointed end. Okay, it is upside down, so to say. And the pointed end of the nail is over here. So what happens is, when we hit with the hammer, when we hit the nail with the hammer, when it is placed upside down like this, the nail of course is not going to penetrate inside this wooden block. All right, because the force that is acting on the nail, okay, so you hit with the hammer, there's a force acting on the nail. Now that force acts on the wooden board also, wooden block also. This force, what happens, acts on a bigger area in this case, so therefore the pressure exerted is less, so therefore the nail is not going to penetrate in this case. Whereas when we hit with the hammer in this case, the force acts on a smaller area over here, the pointed end. The force, the same force, say for example we hit with the same force, okay, so when we hit with the same force, the thrust acts on a very small area, since this is the pointed end. So it is because of this, what happens is the nail penetrates into the wooden block. So remember, if the area on which the force acts is less, then the pressure acting on that surface will be more, and if the area is more, then the pressure will be lesser. Remember that. Now let us look at factor number 2. Factor number 2 is the magnitude of the thrust acting on the surface. Okay, mathematically we write it this way: pressure is proportional to F. This is the proportionality sign. So we read this as pressure is directly proportional to the force or the thrust. This means the more is the thrust, more will be the pressure. The lesser is the thrust, lesser will be the pressure. The thrust is zero, the pressure will also be 0. This is what is meant by directly proportional. Remember that. Okay, so so if the thrust acting on the surface is lesser, the pressure will be lesser. If the thrust acting will be more, the pressure acting will be more. Of course, if there's no force acting, there will be no pressure. To give you an example, let us take the example of this nail, force acting on the nail. So let us suppose it's the same two nails. Okay, so you try pushing the nail with your finger, with your thumb on a wooden block. Okay, we won't be able to do so, or if we can, it will be very, very difficult for us to insert this nail on the wooden block. Okay, but if we take the help of a hammer and we give one blow on the head of the nail, what happens is this nail simply enters into the wooden block. So what is happening? The area on which the force acting is the same, that is the tip of the nail. In both the cases, the area is the same because the tip of the nail is the same. All right, but what is happening? The force is changing. Of course, when we are using the hammer, the force acting is more, or the thrust acting is more. So more is the thrust acting, more is the pressure. So therefore, this nail simply penetrates. Whereas the thrust acting is lesser in this case, and therefore lesser pressure is exerted. Remember that. To give you other examples of increase or decrease in pressure, let us talk about these cutting tools. A knife, axe, a pair of pliers, a pin, nail, stapler, a pair of scissors. Okay, so what is common in between these cutting tools is that they have sharp edges. Okay, now why do they have sharp edges? They have sharp edges so as to decrease the area of contact. Okay, the sharp edges have small areas. So since the area is small, the pressure increases. When you apply a force, what happens? The pressure increases, so it becomes easier to cut using these instruments. Okay, another example, pointed heels of footwear exert more pressure on the ground than regular flat heels. Okay, so you must have seen ladies wearing pointed heels. Okay, so what happens is, since the heel is pointed, what happens is the pressure exerted is more. Why? Because the area of contact in case of pointed heel sandals is less. To give you another example, Heavy trucks have 6 to 8 tires instead of the conventional 4 tires. Now, you must have seen light vehicles like a car or your pool car, okay? They have a total of 4 tires. But in trucks, in our area in Darjeeling, we have seen trucks with 6 tires. 2 tires to the front and 4 tires, a total of 4 tires on the rear side of the truck, okay? So why is that so? All right, that is because tires are loaded on the rear side. Sorry for the mistake here. It's not tires are loaded on the rear side, it is trucks are loaded on the rear side. Okay, so this load is going to apply thrust or a force. So what happens is, if we use more tires on the rear side, what are we doing? We are increasing the area. So when we increase the area, what happens is the pressure exerted on the ground decreases. All right. Another thing, a camel can move conveniently on sand in the desert, of course, as compared to a horse. Why is that so? Because the camel has broader feet compared to a horse, remember. Okay, that is why when it has broader feet, what happens is the area of contact increases. Since it has broader feet, the area of contact increases, because of which the pressure exerted by the camel on the ground decreases. Okay, that is why it is much more easy for a camel to walk on the desert than it is for a horse, remember. So this is the reason why the camel is called the ship of the desert. Another example, skiers use long flat skis to slide on the snow. Okay, so what happens is the skis that skiers use to ski, of course, on the snow, they are flat like this. They are flat sticks like this. Okay, so what happens is people, they place their feet on the skis and they slide over the snow. So what happens is, since they are flat, the skis are flat, okay, the area of contact increases, because of which the pressure decreases and people can nicely slide over the snow since the pressure decreases. Another example, you don't have to discuss all of the examples, okay, so I'm only showing you some important ones and things that we can relate to. Foundation of buildings are kept wide. I don't know whether you've seen a building being built. Okay, in the first case, whenever people are building, so what happens is they have to lay the foundation of the building. So whenever a foundation is laid, the foundation has to be kept wide. Why? Because the building is going to, when it is built, when it is completed, it is going to exert pressure. It is going to exert a force. As the foundation is kept wide, the area of contact with the ground increases, so therefore the pressure exerted by the ground will be lesser. Okay, school bags and shopping bags have broad straps or belts. Okay, why? Because the straps or belts are flat, thereby increasing the area of contact, and the pressure thereby decreases on the hand or the shoulder. Another thing that we can relate to, we have seen wide wooden sleepers are placed below the railway tracks. Okay, so these are the wooden sleepers. These days, if not wooden, you see one made up of concrete itself. Okay, so these wooden sleepers are flat, thereby increasing the area of contact with the ground. So whenever a train passes, say for example, the force that the train exerts is applied or is exerted on a bigger area, because of which the pressure exerted by the train decreases. Okay, so I think this much will do for this video. Next class onwards, or I mean next video onwards, we are going to look at liquid pressure.